Hi guys, we are back. We've got the printer set up. We've got power running to it. Still got a little bit of a wiring mess, but that's kind of irrelevant. This is all about getting this thing to operate well. One thing that you're definitely going to need for fine tuning is going to be some needle nose pliers, and I think that's a 2.5, 3. This is a 3, the third hex bit. So what we need to do is tighten everything up. And I've kind of gone through and done most of the tightening already, but here's how it's done. You're going to start off, if you notice like my sensor here, this is a little bit loose. Start by making sure that your switch is compressible, and you can either use you can use this guy and kind of just tighten this guy up pretty good. So the switch is in the right place. If it clicks, you can tighten this up and make sure that you get a pretty good amount of play. You can check under here, make sure that it's not too close, or it's not too close, but you're not wasting room. Once that's good, the next thing you need to do is adjust this guy. So we're just going to assume that we're pretty close on the proximity sensor, but to be 100% sure, you can just manually bring this down, even if it's powered. Show that's in view, yeah. Even if it's powered, you can bring this down, and as it starts getting close, either the nozzle will hit first, or the light will come on. Now this time the light came on, because I'd already dropped this down a little bit. So in order to drop the proximity sensor down, you'll loosen this nut. You'll also loosen this screw, and what you're going to do is get down low and check about right where the nozzle is hitting, and kind of right in that region verify that the light comes on and goes off. If the light's on, the nozzle needs raised. So you'll manually kind of slide, like kind of twist and lift the nozzle up until it kind of comes off, and then you'll drop down, and that's about perfect. That's right where I need the nozzle to be, about a note card's thickness, maybe a little further away from the plate, maybe like 5 sheets of paper thickness, 2 note cards or so. So this will then be tightened. You can also tighten the little bottom screw. And then double check that this is pretty darn tight. Make sure it's also straight. And you can double check it. It should make sure that whenever you drop this down, it hits, the light turns on like before it hits the plate, just barely. Okay, the next thing we're going to do is tackle this guy. This rod, this Z lead screw has to be perfectly vertical. So you're going to put your thumb here, and you're going to loosen this and loosen this, and you should be able to kind of adjust that Z screw until it's perfectly vertical. And if you can't adjust it, if there's too much resistance, then you'll have to loosen the belt and give a little bit of room on the belt until you have enough play. You've opened up the belt far enough that this thing can slide over. Then you'll want to retighten this thing. So pushing it over, I got this thing pretty darn close to center. It should be pretty smooth sailing whenever I rotate it. Okay, now we need to make sure that these are pinched together. These two on the front side, they can only go in one position. So you're going to start by tightening both of these guys up. Okay, you can go ahead and tighten those, but let's go back to this guy real quick. These can only be in one position, so we've got these tightened already. These are the ones that need tensioned. So let's go ahead and tension those. How I do it is I use the needle nose pliers, grab the hex head, loosen, and I squeeze the 2 wheels together and kind of lift all at the same time, retighten. And I can do that to both sides pretty easily. It takes a little practice, but once you get it once or twice, you can, how's the fan? You can pretty much get all the play out of that system right there. And that play goes this direction. This one, you have play that goes this direction as well. I can feel a little bit in there. So we got to get rid of that. And that's by compressing these wheels together and these wheels together. These are solid state, and we just tighten those up. Solid state. We just tighten those up, so we're going to do a similar process where we pinch the wheels together, and at the same time, we're trying to slide the bolt inward and tighten. It takes a little bit of doing, but once you kind of get the feel for it, it's not too difficult, and they really hold pretty well. This is a bad angle for me, so I'll try to get under here. Oftentimes you can push the bolt head and also push the hex nut that way. And so these are the two down here on the back that actually slide inward. So let's go ahead and get the second one. I'm loosening, so there's some play in there. I pinch here and pinch the bolt head and push them together while I'm tightening. Something like that. Should have eliminated the play. Yeah, it feels a lot better. I don't have that little click in there anymore. Okay, so that's one axis, two axis. The third one's down here. Slide this guy backward. Let me make sure I'm in camera. Yep, I'm in camera. Okay, so this guy is solid. He doesn't go anywhere. So you can tighten this guy. This guy doesn't go anywhere. He can be tightened. Hopefully you don't have to drop your board. I have the nuts on the top because it should tighten up on it like that. This is kind of a difficult process. Not so much this guy, but the front one is difficult. So how you'll tighten this is very similar. You will pinch this, grab the bolt head underneath, pull the bolt head towards the wheel that way, loosen, push in, and tighten. So I'm squeezing the two together. I'm also pulling the pliers. I'm loosening, pushing inward, and retightening, just like that. And that should have eliminated any play in that system there, at least in that wheel. And then you got one more. Total of 6 wheels have to be compressed and tightened. And so it may take 1 or 2 tries, but this is the tough one. There's no really easy way to do it. It's more on luck. If you have to drop the board, it kind of sucks. You'll have to rotate it down a little bit, and then you have to reassemble. But it can be done. Hopefully, you can just tighten this a little bit, and there is no play in the system. And I would say I've got 98% out, and I'm going to call that good. I could probably get it a little better, but if I see a problem in my prints, maybe I'll drop the board. I don't know. I think it'll be alright, though, as it is. One other thing I did not cover with you guys was, what is this big long bolt? I was sitting there thinking, yeah, it's a spool holder, obviously, Nate. It's a pretty simple spool holder. I'd like to think it is. I didn't realize it was that tight of a thread. Thought that was a lot looser. Ha, there we go. I have to loosen that hole up so it just slips through in the future. Yeah, so this whole thing needs to be threaded in. I guess you could... Oh, those will be fast. Maybe there's a better way to do this. 1,000 ways to make this work. Ah, it feels fast. Okay, so yeah, the spool is going to be as simple as bolt this all the way through. This guy goes all the way in. And then the reason I have 4 screws is you can adjust the tracking. There's much better spool holders out there. And yeah, this is kind of perched up high and kind of puts pressure in the back. But it was a really, really quick, fast solution that cost very little money. Trying to keep the cost as low as possible, but do things that are efficient, and still using a lot of high quality parts was really the goal of this printer. So yeah, you can 3D print your own spool holder, but this works great for at least a starter. I mean, it's what I use on the entire farm, and I run through, you know, quite a bit of material daily. They're holding up just fine. So, all right. So the spool holder basically just sets down. It's like a little peg, plugs in like that. This filament drops in around it, like so. I think I prefer to drop it downward off this side and run in that way. Of course, it helps if you have a large plastic spool and not just a little bit of strand. We can go ahead and do one more final operation called auto homing, and it's not, you're not Z leveling or anything, you're just homing the printer to, I believe, the center of the table. Oh no, we're gonna jump back. Prepare, and then go to auto home, and this should be a pretty smooth ride all on its own, I hope. Yep, Z probe caught. So that's good. Everything worked as expected. What I can do real quick, just for the fun of it, is to print out a piece. I do have an SD card with a little part in there. And you're going to need some blue masking tape. So this is just Duct brand, Walmart. Get the wide stuff. It goes on a lot faster. And the part that I have in there is pretty small. I think it's located, and you'd put 4 strips across this, and I believe the part that I have designed is located somewhere in this region. There's a little bit of alcohol on the surface, or there's a little bit of grease on the surface of this plate, so you're going to want a cleaning solution just to break that down. Alcohol, something. Okay, it should be sufficient. One more run. Of course, Build Tack, in my opinion, is some of the better stuff. A little bit expensive, but nope, it's not working. All right, so I would recommend using alcohol, rubbing alcohol. A lot of other cleaners are going to have greases or residues or something in them, apparently. Good old isopropyl alcohol should get any greasy material off of this aluminum bed, and this tape will stick. Blue tape is a very fast, quick solution. It's cheap. It works almost every single time. There are very few prints that I have that fail on blue tape. If you guys saw that, yeah, it's a little better centered. Can't quite see the camera. All right, so to print, I'm going to raise this up just a notch by hand. I'm going to go ahead and tell it to print. It's going to rehome. It's going to home this axis, and then it's going to home this one, and then it's going to home the Z, drop down, and then it's going to come up, and it's going to tap here, 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 like each corner in the center. And then it's going to return over here. It's going to start heating up. To prepare for the actual print, what I need to do is take a little bit of this plastic. Loading filament can be difficult. The secret is getting this thing straight. The filament here, you need to get that super straight, and you may have to cut this at a slight angle, like a sharp point kind of, using, you know, scissors or pliers or something. Now when you insert this, you can just turn the wheel and you'll feel it grab, and hopefully it'll thread straight through, and you'll actually see it feeding through here, and I can actually see it moving back and forth in there. And then, of course, you don't want to turn the wheel the whole time, so what I do is I grab the lever and then feed it through by hand. Until I just saw it drop in right here. I can actually see it move back and forth. So I want to feed that all the way through as far as I can go without really forcing anything. It almost feels like there's a scraping going on in this brass, and it might be that Teflon isn't fully seated. We'll see. We will see. So every printer is going to be a little different based on how you install it. The components may vary a little bit, but a lot of these components are really inexpensive. You can get them off eBay for like less than $1 for a little brass coupling. The Teflon tube you can get for like $1.50, shipped out of China on AliExpress or Alibaba or DHgate or whatever. Okay, so let's go ahead and start this thing. See what happens. I hit enter. I go down to print from SD card. I go to, I got something called sticks. They're like little quadcopter sticks, and hit go. It goes left, it goes back, centers, it homes. As long as that's right, it's going to then feel this corner. Back, and that one. If you notice on the LCD screen, it just jumped up to 205. This is its current temperature, 25 degrees. That's how Celsius is what it is in here. The bed is set to 0, so it's not heating the bed. It's just doing 205 on the hot end. It says heating. You can see the location of X is at 10 millimeters, Y is at 10 millimeters back, and Z is 15 millimeters off the surface. Now, when it tapped the corners, it created a imaginary plane that's tilted based on where its readings were. So it's actually going to follow the contour of that plane and attempt to keep a level surface, the nozzle to the surface. Now, when I start off printing, oftentimes I'll turn the speed down. The very first layer is extremely difficult to get to stick really well. That's where it's all at. So you can see the feed rate is at 100. Unfortunately, that's just homing feed rate. So I can turn this down, but it's not going to do much for me. Like turn it down to 50. Just drop the speed down to like 20, 25 millimeters a second. It's not going to do much for me because as soon as this hits temp, 205, it's going to kind of take off. You notice it's at 181. At this point, go ahead and squeeze some plastic out. You should see plastic come out of the nozzle. At 160, 170 is about where it should be ready. So this is at 201. It's starting to slow down the heat up. You can see it drop back to 200. It's going to reheat because it realized it didn't make it. As soon as it starts printing, what I'm going to do is drop the feed rate again because I want it to start out a little slower, and then I'm going to adjust the height by overpowering the motor and make sure it's at exactly the right height. It's a little bit high, so I had to overpower the motor 2 or 3 times. Alright, it's printing. A little higher would be a little safer. Looks like it's doing good. Yep. Doing great. Alright, so you guys probably can't actually see the print, so I'm going to put this up for you guys to see it. Because this thing is actually really stable. There it is, maybe. I don't know if you can see that in the light. Let's see if I can home in on it. It's pretty far down there. Pretty challenging to see. Well, anyways, it is printing. It's doing really well. The parts are coming out pretty clean. I'm literally holding this printer at all kinds of different angles. So this thing's robust. It prints. I mean, everybody's like, wow, I can't believe that guy can print upside down. Well, mine prints upside down too. But the top might come off if you don't have it secured under here, right? Okay. So anyhow, looks like the parts are coming out pretty decent. For a very first print, untuned really, I quickly tuned. If I see any disturbances in the print, then I would make adjustments accordingly. So it's kind of a process, but that should be the whole setup and print. We will go over setting up your card and how to get everything operational for the STL model, make your own stuff. We'll do that in the next video. Hope you guys enjoyed, and we will see everybody soon. Thanks, guys. Bye.